Good afternoon. We're doing this project on partial fulfillment of Mechanical Design 1 coursework. This is Design Project Number 1. I am Ryan Sheffield.
I'm Alfred Salas.
I'm Rojas.
And we are the team presenting on the mini Formula race car focused on the differential. What is FSAE? Formula SAE is a competition that tests the design capabilities of students and the maximum performance of the completed vehicle. The basis of FSAE is to simulate a small company who must design a Formula-style race car from the ground up. SAE must design, manufacture the car from the ground up in an effort to place well in the yearly competition in Michigan, in which there will be competitors from universities all around the world. This project will focus on improvements that can be made on the previous season's differential, as there were a couple issues hindering the progress of this car. FIU has chosen to go with the torsion differential, mostly due to budgeting constraints, versus the top competitors who usually go with an adjustable Drexler differential. What is a differential? A differential serves a couple key purposes. It must transmit the power from the drive shaft to the wheels. It acts as a final reducer in the gear ratio, and it must control the wheel speeds. The different type of differential are the open differential, as can be seen on the right, a closed differential, and a limited slip differential, as can be seen here. This one in specific is a torsion differential. A torsion differential is a gear-based differential versus the Drexler differential is a clutch-based differential. They're both limited slip differentials, so they will serve the same purpose there of being able to control the wheel speeds under traction loss. Versus the open differential, it does not have this capability, and under traction issues, all the power will be lost to the wheel that does not have sufficient traction. And a closed differential, both wheels be transmitted the same amount of power. These are the applicable FSAE rules to the differential. I'd like to highlight a couple. Right here, any cooling or lubrication system must be sealed to prevent leakage. During last season, the differential was leaking, which renders the car disqualified. They can't compete. And it also must go through the tilt test, in which the car will be tilted at 45 degrees, and the reservoir will have to be full, and it cannot leak anything.
These are two alternative designs for the differential. As you can see on the left-hand side, this design is actually called an inboard differential. And it's a little bit difficult to see, but as in here inside of the chassis, the differential is actually located at the center of the chassis. These are one of the most common designs because as far as placement and how near it is to the power unit, it allows for easy alignment of the chain as well as adjustability. Another option that teams use is an outboard differential. This one is also called the free floating, and the difference between this one is that, as you can see here, the differential is actually outside of the rear of the chassis. And the main reason why it gets its name free floating is because the differential floats at the center rear of the chassis, but is not in the middle of the chassis supports of the rear. So for the 2014 season, as you can see here, it was a inboard differential. One of the main issues for this design was, number one, some alignment issues. Number two, lack of adjustability due to the triangulation of the chassis. And number three was the mounts here caused for leaking. One of the last updates to this differential was seals to be placed in here, which still allowed for the chassis to leak. For the first iteration that we have designed as a team is for the free-floating differential, a bracket which uses the same size bearings, which was also another issue for the 2014 season. One of the issues that we first came upon here was alignment of the differential as well as interference of the sprocket with the rear of the chassis tubes. What this created was a necessity to create a bracket which had a notch. We haven't done any stress test analysis or any finite element analysis, but due to the lack of material as well as the small amount of material there, we decided that that was not the best design. For the final iteration, working with the chassis team as well as the chief engineer, we decided to add a plate to the rear of the chassis. What this allows for is direct placement of the differential as well as a bracket which needs no notching, which was required in the first iteration. With this bracket also allows for is the same size bearings as well as no clearance issues or any kind of interference, as well as the lift point which is required on the free-floating differential due to the fact that the lift points is not part of the chassis. One of the actual future bracket design, due to time constraints as well as the manufacturability of the piece, one of the issues that is still slightly present is adjustability. Even though that this is perfectly aligned with the rear uprights of the chassis, and there's actually no induced angle in the axles, for future designs, one of the biggest factors is adjustability. So right here, as you can see, for our future design, this is actually a bracket with a cam bolt type of bracket, and what this allows for is for the removal of bolts and the adjustment. And when this actually turns, this offset circle in the center here would actually change the geometry as well as the position of the differential. This would allow for induced angles in the axles to reduce any possible vibration, as well as the adjustment would allow for changing any type of chain tension. So if there's too much chain tension or too little, all of those factors can be simply adjusted by the future design bracket. One of the also other design iterations that we had to go through was the differential housing. As previously mentioned, the first differential housing had issues with leaking. And the reason being is, even though it's a little difficult to see, the two ends of the differential were different. This caused for two different types of bearings to be used. Therefore, the brackets were designed for the larger bearing. What this caused was a sleeve and multiple pressing operations just to be able to get the bearings onto the differential housing. For the new design that we designed was to use a differential, however, with two sleeves that are slide fit, which will be welded to the housing. Secondly, on the inside of the sleeves, there's actually a grease sleeve fitting that will actually be placed inside here to actually prevent oil leakage. Secondly, these two sleeves will actually allow to be use the same size diameter bearings, so no two different size bearings will be used, and this will also allow for simplicity of disassembly and assembly of the differential housing.
During the design phase of our differential, we took three main points into consideration: the manufacturing feasibility, the assembly and disassembly, and the manufacturing. Manufacturing feasibility turned to be a main point in our design due to the fact that FSAE Panther Motorsports is a 2-year group and has limited resources in terms of tools and funding. Assembly and disassembly was observed to be a main point in our design due to the fact that in inspecting our previous year's differential, it was damaged due to the design of the bracket assembly. Maintenance, although there is little to no maintenance needed to be done on the Torsen differential, it is always a possibility that there is damages to the seals or any internal components that must be repaired and serviced on the track. Conclusions. It may be said that a differential was successfully designed and it addressed the flaws in the previous design, such as fluid leaks, alignment issues, adjustability, and accessibility. In addition, a potential future design was prepared for the 2016 season, providing the team with a starting point and without having to start from scratch. Here you can see our project management. Any questions?